Hi everyone. So in this video we need to study about divergence and curl. So both are operator only and both will be studied by del operator. So what is divergence? So divergence, what is the initial word? D. So divergence is the dot product, and if it is a dot product, that means it would be happening between two vectors, right? Because divergence is a dot product, so it will be happening between two vectors. One vector we have del operator, another vector field we will have. So this A is the vector field, right? We have already studied the meaning of vector field and scalar field. So this is the vector field. So divergence will take place between a vector or vector field and del operator. So this is the dot product. So in what flow we will go? Formula based problem, and then we will see the physical significance. But in this lecture we will only study about the sign of divergence, and same goes for curl. We will only see the direction in curl. So that I will tell about curl as well. So here we will only see the sign, but what magnitude will represent, that we will see when we study integral calculus. So in the integral calculus as well, divergence will be used. So that I told you, divergence will not be completing in this lecture itself. It will be used in lectures of EM wave as well or in integral calculus as well. So in this lecture we will only study about the sign. So what is, first we will see only formula based problem. So it will be completely a rote learning. So it will be something like that, because in the same manner we studied gradient as well, right? There also we did the rote learning first, then we went to the interesting part. So first we will write down the formula of divergence. So in Cartesian coordinate system, divergence of A, how that will be defined? So that will be defined as, what we are going to write? Del x, del y, del z. So del by del x, Ax, because del by del x Ax cap, so only Ax part will come, plus del by del y, then Ay part will come, plus del by del z, then Az part will come. That's it. Now for this cylindrical coordinate system, so first you are going to write d rho, rho d phi, and dz, right? So here there will be something different. So what I am calculating? Divergence of A. So how I am going to write it? D rho is there first. So d by d rho, A rho, right? Plus, this is not completed, okay? 1 by rho d phi, 1 by rho d phi, A phi, d by dz, Az. So first you will write down this. Now in this cylindrical coordinate system, there will be change in the first quantity. Look, in Cartesian you did not have any problem. Del x, del y, del z directly you wrote. This is just a way to remember. I am telling it. Okay, you can see the derivation in any of the YouTube video. Nowhere it will be used, and no one will tell you as well. Like in some YouTube videos of mathematics, you can see the derivation of this. But you just need to remember the final answer. So this was the final answer for Cartesian coordinate system. It was very straightforward. Del x, del y, del z, Ax, Ay, Az. Now this is very straightforward. In cylindrical, in the first term there will be something different. What that will be? You will have to divide by rho and multiply here by rho. That's it. This was very straightforward. Here there will be issue in first term. In cylindrical there will be issue in first and second term. Okay. So there will be one issue in the first term. What is that? Here you can write down this very easily. This is very easily. This also you can write down very easily. Just you need to remember one thing, that I will add 1 by rho here and multiply by rho inside. That's it. If you write it down for 4 to 5 times, you will be able to remember it. Now let's talk about spherical. So dr, r d theta, r d theta, r sin theta, d phi, right? So let's start. Divergence of A. And what kind of quantity it will be? What will be the final result? Scalar, right? Vector dot vector. Final output will be scalar, because dot product will always give you scalar output. So del dot A. So how you are gonna write? So first I will write just here plus 1 by r d theta. So 1 by r d by d theta, a theta. plus d by dz az. Sorry, not z. Z is not there. And what I am doing here, r comma theta comma phi. Really sorry. This was a phi actually, right? R comma theta comma phi. R comma theta comma phi. AR etc. A phi. Okay. So what you are gonna get? 1 by r sin theta d by d phi and a phi. So here there was a problem in first term. So in the first term, what did you do? You multiplied by the radius of cylinder. You multiplied by the radius of the cylinder. Here also you will multiply by the radius of the sphere, but you will do the square. Look, here you multiplied by the radius directly. Here you will multiply by square. So if you are multiplying here, you have to divide here as well. Now here there was issue in only in first term. In the first one there was no issue. Then issue was there in first term. Then here issue will be there in first and second term. So here also there will be one issue. What is that? We need to make this and this same. Here what you are getting r sin theta, so you will have to multiply sin theta here. If whatever that you are multiplying here, that also you need to put here. That's it. Look, no one will even tell you this trick, that I can guarantee you. Okay, you people must have studied it from somewhere else, but this is how I remember. So directly we can write down the formula. I could have written the formula directly as well, but one way I am telling it, how you can remember it. Okay, that H1, H2, H3 formula that certainly you cannot write in the examination. You will not be able to write down that formula in the examination. I am telling you, that is not practical. Like that formula I could have written H1, H2, H3. Those who have studied this particular topic, they would know what I am talking about. But in that manner, you will not be able to solve the problems in the examination. So in this manner, for cylindrical and spherical, for Cartesian it is very straightforward. For cylindrical, what is the trick that I am telling it? In the first term, there will be a problem. In the first term, there will be some change. Otherwise, d rho, rho d phi, dz, no issue there. So in the first term, what will be the change? You will multiply by the radius of cylinder. And here, there will be problems in two terms. dr, r d theta, r sin theta, d phi. So in problem will be in two terms, first and second. So here you multiply by the radius, so here you will multiply by the radius square. Here you need to make this and this equal. So sin theta here and sin theta here. Because r is there, sin theta extra you need to add. If you multiply sin theta here, then also here also you need to multiply it. So if you write it down for 3 to 4 times, you will be able to remember it. There is no doubt about that. Okay, so let's solve the problem. It will be completely formula based, nothing like no brain, nothing, just rote learning it is. But it is important as well, because learning the formula is also important part. So just you need to solve by simple formula. So what you are going to write? Del by del x, then ax term will come, ax cap term will come, that is x square yz, plus del by del y, then ay term will come, ay term is not even there, 0, plus del by del z, then xz will come, z term will come. So what you are going to get? 2xyz plus x will come outward, dz by dz will be 1. So this is the answer you are getting. But at what point you need to calculate? At 0, 2, 1. So del p, what that would be? If you put x equals to 0, what you are going to get? 0. So your del p is coming out to be del p. I should not say del p. Okay, that is very wrong. I should say divergence of p is coming out to be 0. At some particular point. At which point? 0, 2, 1. At some other point, the divergence would be non-zero as well. If I had asked you divergence of p at 1, 1, 1, that would be 3, right? So it could be different as well. So here divergence of q you need to calculate. So this is mentioned in cylindrical coordinate system. So in the first term there will be some problem. Otherwise rest all will be same. Rho into this term. So rho square sin phi. Are you getting this point? What did I do? What was the first term? D by d rho, a rho. But I know there is some problem, 1 by rho into rho, a rho. And what is the value of a rho? A rho is rho sin phi. So this I am writing. Rho into rho sin phi. So that would become rho square sin phi. Say yes or no? Plus, after that there is no issue. Directly it will come. Rho d phi. 1 by rho d by d phi, and then phi term will come, that is rho square z. Then z, d by dz, then z term will come, that is cos phi. Okay, so now what will happen? Just a second, I will switch it off. Flight mode, otherwise it keeps on disturbing. Okay, doubts आते हैं ना WhatsApp group पे. I clear all the doubts, okay. I do not ignore it, but once I am recording the video, so how I am supposed to clear the doubt. So later on, once I am done recording the video, then I will clear the doubt. Okay, yeah. So what will happen now? Sin phi is constant, that will come outward. So sin phi by rho, then rho square, that will be 2 rho. Sin phi is coming outward, sin phi by rho, then differentiation of rho square will be 2 rho. So what you are gonna get? Rho and rho will get cancelled, 2 sin phi, right? Very easy. Plus what this will be? 0 only, because differentiation of rho square z with respect to phi 0. What about this? Cos phi will come outward, del z by del z will be 1 only. So 2 sin phi plus cos phi. Now at what point you need to calculate it? 1 pi by 3 and 2. So only phi term you need to put. So 2 sin pi by 3. Pi by 3, what is pi by 3? 60, right? So sin 60 under root 3 by 2. So 2 into under root 3 by 2 plus cos 60, 1 by 2. So that would be root 3 plus 1 by 2. So this is the answer. Okay, I hope there is no calculation mistake. Let me check it. Are we getting the same thing? Because these questions are very straightforward from directly. I have taken it from Sadiko's book. So from this book I am taking it. This is the book of reference I am taking. So 2 sin phi plus cos phi. Then phi value is 60 degree. So root 3 by 2 and 1 by 2. Okay. Let's solve the last one. You apply the formula on your own and then try solving it. So what will happen? In the first term there is some issue. Should have come directly dr, but r square into ar. R square into AR. So R square into 1 by R square cos theta plus dr r d theta, dr r d theta. So 1 by, but there is some issue, sin theta will come, d by d theta, sin theta into, oh here I forgot to write down R square. Look, these kind of error we do. These kind of errors we do. Okay, sorry. R square will not come because R square into this term. R square into this term. So R square got cancelled and cos theta would come. So directly cos theta would come. Okay, there was no error from my side. So here sin theta would also come. Sin theta into R sin theta cos phi. Sin theta into R sin theta cos phi. So what that would be? R sin square theta cos phi. So that would be R sin square theta cos phi. One by R sin theta d phi. So that will be cos theta. Okay. So R theta phi and that will be cos theta. Now let's see. What this will give you? 0. Because cos theta is differentiated with R. So cos theta is constant with respect to R. So that will give you 0. Plus what this will give you? 1 by R sin theta into 2R sin theta. Differentiation of sin theta will be cos theta. I hope you know how to differentiate it. And cos phi will be constant only. Cos phi will be constant, R will be constant, sin square theta is being differentiated. So 2 sin theta cos theta, 2 sin theta cos theta. Okay. Sin theta getting cancelled, R and R are getting cancelled. So 2 cos theta cos phi you are getting. Plus this will also give you 0 because cos theta is being differentiated with respect to phi. So this will also give you 0. So what is the answer we are getting? 2 cos theta cos phi. And at what point you need to calculate? Two pi by 6 pi. 2 pi by 6 pi. So 2 cos pi by 6 into cos pi. So 2 into root 3 by 2. Cos pi by 6 is cos 30. So that is root 3 by 2. Cos pi is minus 1 minus under root 3. So this is the answer you are getting. Okay, so here you are getting negative answer, here you are getting positive answer, and here you are getting 0. Let's see the physical significance of divergence. So what is these arrow? These arrows are vector field lines. Okay, these arrows are vector field line. Now there is a point A, there is a point A. Here vector field lines are going in, right? At the point A, vector fields are going in. So divergence of A, here I am telling physical significance only about sign. Only I am discussing about sign. What will magnitude show? That we will see when we study integral calculus. So this I have already told in the beginning of the lecture. So what will magnitude show? That we will study in the integral calculus. So now vector fields are coming into point A, right? So what I am gonna write? Divergence of this field. This field is F vector. Here P vector, Q vector and R vector, what they were? They were vector fields, right? They were vector fields. So divergence of vector field F at point A will be negative. Why it is negative? Because it is telling that field lines are coming in. If you are standing at point A, what you will feel? That lines are coming into me. If that is happening, that lines are coming into you, then divergence will be negative. And if it is going outward from you, then divergence will be, if it is going outward from you. So this is also F only, field is F only. I am considering all the field are F only. So divergence of field F at point B will be positive. Flowing out, it's like a flow of water. That water is flowing in. At point A, water is converging. Here it is converging out. At point B, water is converging out. So it is spreading out, then it will be positive. If it is spreading in, then it will be negative. Think about it. Think about it. Tell me what will be the value of divergence at C. You think that this intensity and this intensity are same. Like whatever the intensity of line are coming, the same intensity of line are going out. So what do you think? What will be the divergence of F at point C? 0. This point C is acting as a source or sink. What do I mean by source? This point B is source, because it's like it is flowing out the water, it is giving us the water, and this point A is called as sink, that this is sinking in the water, this is taking the water. Source means flowing out. This term you don't need to remember, just for the reference I am telling. B is acting as a source, so it is giving us field lines and it is taking field lines. A is taking field lines. So what do you think? What is happening at C? Whatever the water it is taking, it is giving the same amount of water. So first it was positive, then for the same amount, first it was negative, then for the same amount it became positive. So divergence is 0 here. Vector field line came and then went away. So small intensity, same intensity of line came and same intensity of line goes out. So here divergence is 0. So here it was 0, here it was positive, and here it was negative. What do you think? What will be the divergence at point D? Positive, negative, or 0? Less intensity of line came, more intensity of line is going out. That means it is acting like a source, right? It is giving us more water. Less water came, more water is going out. Positive. And what about this? More water came and less water is going out. So divergence would be negative. So it's like it is taking up some water. But these are not water fields, like these are not flow of water, but they are the vector field lines. So this is acting as a source, this is giving us vector field lines, this is sinking in the vector field lines. So negative here, positive here, this is neither giving, neither taking, 0. This is giving us, because less is coming, more is going out, and more is coming, less is going out. So here it is negative, here it is positive. Well and good, very straightforward, right? So this was all about divergence. And what does the magnitude show? So it is total outward flux per unit volume. You do not know what do you mean by flux and what do we mean by very small volume, per unit very small volume. So it is shown by total outward flux per unit very small volume. So first I will teach you about flux, then I will talk about what do you mean by small volume and what does divergence represent, but that we are going to study in the next lecture. Okay, in the next lecture of vector calculus, there we are going to start integral calculus, so there we are going to see it. So do not worry about it, this will come. Okay, so explanation next lecture, next, or it could be possible that in the next lecture of that lecture, like on the second lecture there is possible that I will be telling it. Okay, or I will try to tell it in the next lecture itself. So explanation I will be giving in the further lectures. So here I would write further lecture. Okay, let's study about curl. So divergence D dot, what C represent? Cross. So this is just an initial way to remember it, but otherwise later on you will be able to remember it only because we are going to use it again and again. So eventually you are going to remember it. Divergence D dot curl C cross. So it will be your cross product. Cross product. And if it is showing cross product, that means it has to be applied on vector quantity, because dot product and cross product both are applied on vector quantity only. So one vector quantity we are already having, that is your del operator. Other vector quantity would be some vector field. So del cross A. Sorry, cross product. And what is the final output of a cross product? A cross B. That will be vector only. So final output is vector. Okay. So again first formula, then formula based rote learning, and then we will see the physical significance, but only we will talk about direction. Here there is no concept of positive negative, right? Because it is a vector quantity. 5 az cap and minus 5 az cap. Which is positive, which is negative? You cannot comment. You cannot say, sir, this is positive and this is negative. Nah. Both have 5 magnitude. One has the direction az cap, another one is having the direction minus az cap. That's it. So here there is no meaning of positive negative. Only the meaning is about the direction. Right? First let's understand the formula. So what we are gonna do? Ax cap, ay cap, az cap. So first we are gonna write this. Ax cap, ay cap, az cap. This matrix, this determinant we are making it. Okay? This determinant we have made ax cap, ay cap, az cap. Then what we are gonna write? Del by del x, del by del y, del by del z. Then ax, ay, az. Ax, ay, az. Okay. Now for this, for your cylindrical coordinate system, what you are gonna write? A rho, a phi, az. Now here you are not gonna write rho, d phi and dz. This you are not gonna write. Okay. So here directly you will write d by d rho, d by or del by del phi and del by del z. Then a rho, a phi, az. Now I am gonna write d rho, d phi and dz. Now I know one thing, that with phi always rho will come, but now the rho will be applied here and here, and whatever that you are applying here, that should come outward as well. You have to remember it, there is no other alternate of that. Okay, you might be thinking that, sir, what you are teaching, why so much of rote learning? But it is what it is. You have to keep it in mind. There is no alternate. I am just telling you trick how you can remember it. A rho, a phi, az. Whenever we study anything which we need to remember, I always tell you some trick, right? When there is something where you do not need to apply the formula, I will never ever ask you to mug up. But here if I teach you some complex formula and then finally I derive this thing, then there is no use of that. Eventually you have to remember it. Trick I have told, simply write down a rho, a phi, az, d by d rho, d by d phi and d by dz, or del by del z you can say. Then a rho, a phi, az. Then I will write d rho, d phi, dz. So this rho will never come alone. So rho here, and 1 by rho will also come outward. Whatever that you are multiplying here, 1 by that multiplication will also come outward. Try writing for this in the same manner. What you are going to write? R, theta and phi, right? Then d by dr, d by d theta, and d by d phi. Then ar, a theta, a phi. Now I will write dr, r d theta, r sin theta, d phi, right? So this will never come alone, r. If r is here, r will come here. A phi will never come alone, r sin phi. Sorry, r sin theta, and here also r sin theta. Phi will never come alone, so r sin theta a phi, r sin theta a phi. So 1 by r into r sin theta, so r square sin theta. That would be the answer. Are you getting this point? Del cross a, 1 by r square sin theta, ar, r sin theta, a phi. So this is the final result. If you write it down for 3 to 4 times, you will be certainly able to remember it. Okay, there is no doubt about that, right? Let's go to the next one. You need to find the divergence of the vector field of these following vector field at these given points. So just write down the formula and do it on your own. Do not watch the solution. Just watch the final answer. Okay. So this determinant I will make, and now I will solve it. So first Ax will come, Ax cap. Then this complete row will be gone, and then del by del y. Okay, first I will write down everything. Del by del y xz minus del by del z 0. Del by del y xz. So only for one question I am writing it all. Plus here I will write plus ay cap. So what will happen? Del by del z x square yz minus del by del x xz plus az cap del by del x 0 minus del by del y x square yz. Okay, so what you are gonna get? 0 minus 0, this will be 0 only, no? Del by del y x is 0, differentiation of 0 0, so 0. Ax cap term is gone. What about ay cap? So x square y minus z will come common, minus z ay cap plus this is 0. What about this? X square z. So here minus x square z az cap. Let me check the answer. I hope there is no calculation error. No calculation error. Okay. So this is the del cross p we are getting. So del cross p, but this is your answer, del cross p. But at what point we need to find it? 0, 2, 0. I guess I wanted 0 answer. That's why I wrote it. 0 minus 0 0 0 0. Okay. What you are getting? 0. But here I will show 0 vector, or you can directly show 0 only, because 0 is 0. But answer is vector quantity, so I am showing 0 vector. Answer is 0 only. There is no issue about that. You can show 0 as well, or 0 vector as well, because it is a vector quantity. So just to show the answer as vector, I am showing 0 vector. 0, 2, 0. So 0. Then here also 0. Here also it is 0. So 0 vector you are getting. Solve this next one on your own. I have done the calculation. I will just write down the formula. How will I write down the formula? Here I will add rho, 1 by rho, and here what I am going to write? Whatever that is there in a rho, that is rho sin phi. Rho sin phi. And in the next term I am going to add rho. So what is that? This is your rho square z. So here what will come? Rho cube z. And z will be written as it is, z cos phi. Z cos phi. I will just tell you how did I do this calculation. So first a rho cap will come, then 1 by rho is outward only. 1 by rho will come with everyone. 1 by rho will come with everyone. So do not forget it. A lot of times even I forget this 1 by rho. So do not forget this 1 by rho. Okay. So 1 by rho will come everywhere. Then a rho term, del by del phi z cos phi. Del by del phi z cos phi. Then del by del z rho cube z. Then rho a phi term will come. I am writing del by del rho z cos phi. That's why I have written negative sign here. If I had put positive sign here, then these terms will be reversed, right? I am putting the negative sign, so that's why first I have taken this del by del rho z cos phi minus del by del z rho sin phi plus 1 by rho. 1 by rho will be everywhere, az cap term will come, so del by del rho rho cube z del by del phi rho sin phi. So then I solved it and put the value. This is the answer I am getting. Okay, after solving it, I will write down only the formula. So how I will think: dr r d theta r sin theta d phi, and then I will write down here 1 r square theta. Okay, and then I will write down the terms. So first term will come as it is, 1 by r square cos theta, 1 by r square cos theta, that will come as it is. In the second one, r will be multiplied, so r square sin theta cos phi, r square sin theta cos phi. In the third term, r sin theta will be multiplied, so r sin theta cos theta, r sin theta r sin theta cos theta. Okay, so ar cap, then this into this is something what I am doing, and then 1 by r square sin theta is also there. So direct result I have written. Okay, so after doing all the calculation, this is the direct result you will be getting. Then all the values I have put, and this is the final answer I am getting. Okay, this is not important for you, this is just as an educator I have to teach it. This formula is important for you. This much rough calculation, there is 0.1% chances is there that these kind of questions they will ask. In the PYQs of 90s or in 2001, 3, 4, 5, you can see these kind of problems, but nowadays the pattern has changed a lot. They are not asking you anything which is too much into calculation, and there is no final result of that. Like, this doesn't represent anything. This is not representing anything. Like, it represents something, but just for solving the problem you did not understand here anything. This was just completely rote learning. So these kind of questions will not come in your examination. I am not just talking about EMFT. Okay, not just about EMFT. In any of the subject, whenever you see that, sir, this is completely rote learning, so that concept is just required to understand the things that will not come in the examination. When we study Maxwell equation, next topic will be our Maxwell equation only. So there you will see in the initial phase I will teach a lot of things which are not even required for your examination. They will not come straightforward, but they are important for understanding further concepts, right? So that thing happens. So you just need to hold your calm, just be calm and proceed in the lecture. So this is the answer we are getting. Now let's see the physical significance, but we will only understand the direction. Okay, so what the curl shows, I will tell you one thing. This is your point A and these are the vector field, right? Vector field lines. So curl shows the circulation of vector field, circulation of vector fields. So how will you understand this? So at point A, if I keep a ball at point A and I am considering these vector lines as force, so if this ball A is getting force in this direction, like this force, and then this force. So this ball A is getting force in this direction. So tell me, where will the ball rotate? First question is, will the ball rotate? Yes, ball will rotate. Basically, what is the scene is that this is the ball and these are the vector lines. So these vector lines are pushing some force across this ball. So I will just consider some ball A here. So that ball A is getting some force. If that is getting some force in this direction, that means ball will rotate. So first thing is that curl will be non-zero. Curl of vector field lines, curl of F at point A will be non-zero. Okay, that will be non-zero. But how will you define the direction? So here I am only gonna tell that will be non-zero. Now what do you mean by direction? So that you will understand by right hand rule. So I will put my right hand. The ball is moving in this direction. So where it is pointing? Inside. Ball is moving in this direction where it is pointing inside. Okay, so the direction will be inside. So how we will represent inside? In this manner. So this is showing the direction. Okay, this is the direction. What do you think where it will rotate? This ball B. Curl of F at point B. Assume a ball where it will rotate. छोटी बॉल नहीं है यार मेरे पास, बड़ी तो थी, ऊपर छोड़ाया मैं. Okay, assume this as a ball only. I am applying more force here and less force in this direction. I am applying more force here. So try assuming it more force here, but force is in the same direction only. But this is more. That means it will rotate, no? It will rotate in what direction? In this direction, right? This is ball B. Here I am applying more force. Here lesser force is there. So this will rotate in this direction, right? So again, curl of B is non-zero. And where will be the direction? So ball is moving like this. Ball is moving like this. Right hand rule. So it is coming towards you. Okay. So let's put that in box. Put this also in box. What do you think at point E? Will the point at E, will the ball rotate? No. It will just be displaced. You do not need to think about displacement. I am talking about rotation. Point E, some force in this direction, some force here. So will it rotate? Someone is pulling and someone is pushing. Rotation will not be there. Displacement will be there, but rotation will not be there. Right? So here del cross E will be 0. Okay, or 0 vector also I can show. 0 vector also you can show, or 0 you can show. In some textbook you can find written 0 vector. What about this? It will rotate in this direction. In this direction. So force will be going in. Are you getting this point? This will rotate in this direction, no? This will rotate in this direction. This will rotate in this direction. So where will be the direction? Inside. So it will be non-zero. Oh, sorry. This is del cross E I have written. That is very wrong. Curl of a vector field F at point E, that is equals to 0. Okay, that was very wrong. I should not write it. So del cross F at point C is non-zero and direction is inward. What about this? The same amount of force here, the same amount of force here. Will the ball rotate? No, ball will not rotate. The same amount of force is applied. This is the ball. Here I am applying the same amount of force. Here also I am applying the same amount of force. Ball will not rotate. Right? So curl of F at point D is equals to 0. Now a lot of guys would be having this query that, sir, what does it represent? So that will come. No need to worry. So that thing will come. Okay, what does it represent? It represents the circulation actually. And you get to know that how vector fields lines are circular in manner, if they are framing a closed loop or not. So that we will talk about closed loop, open loop, closed loop, open line integration, closed line integration, open surface integration, closed surface integration, volume integration. So that we will talk about in next lecture itself. And here curl of F at point F is equals to 0 only, because here also it will not rotate. More force here, less force here. This is also pulling it. This is also pulling it. No rotation. And certainly here also there is no rotation. So curl of F at point G. Here also there is no rotation. Okay. So all these are 0. Here this was the direction inward. Here this was the direction outward. Here this was the direction inward. Okay. Well and good. So what does the magnitude represent? Maximum circulation of a vector field per unit very small area. Divergence was what? Flux per unit volume, per unit very small volume. This is very small is known as infinitesimal. in phi, so in some book you can find this thing written infinitesimal. So this is also written infinitesimal means very small. This is a complex word, so that's why I don't use it. So in some books you can find infinitesimal word also written. So maximum circulation of field per unit infinitesimal area or very small area. So meaning we will be studying in the next lecture. So explanation, further lectures. Okay, just for the sake of writing I have written it. Explanation will be given in further lectures. Laplacian operator. So let's study it after a break. 40 minutes is there. So 40 minutes have been completed. So I will take a break, drink some water. You can also drink some water and then you can start. This is a very simple operator, Laplacian operator. Everything that is necessary has been written on this page itself. Okay, so you take a break and then let's restart. Okay, so let's see Laplacian operator now. So there I wrote the line, initially I wrote a line there that it can be applied only on scalar function, but that line I wrote mistakenly. You will be using it only for scalar function. You will be applying Laplacian operator only on scalar function, but it can be applied on vector function as well. Okay, it can be applied on vector fields as well. So what is your Laplacian operator? This is your Laplacian operator, del square. Del square is your Laplacian operator. In some derivation it will be used, it will never be asked in your examination. So in this chapter you need to remember three terms. What all are the terms? dg, cg and dc. These two will be very easy to remember. CG, CGPA, DC, DC current, direct current. So CG, CGPA, what is your CG? 0. What is the direct current in capacitor at steady state? 0. Direct current is also 0, CG is also 0. So these are known as null identities. So we will discuss about it later on. One more term you need to remember, DG, which is your Laplacian. This is your Laplacian operator. What do you mean by DG? Divergence of gradient. What do you mean by CG? Curl of gradient. What do you mean by DC? Divergence of curl. So divergence of gradient is del square. This will be easy to remember. How will you remember this one? DG. So there is a word GD. Do you know the meaning of this word GD? Group discussion, right? Group discussion. So in GATE examination, you can never do the group discussion. Imagine going into the examination hall and there people are discussing your answers the way you do in Telegram group. So that can never happen in your GATE examination, right? Discussion can never be there in GATE examination. So GD we never studied. So what we studied? DG. Very poor way to remember it. Okay, very poor way. It is a very poor way to remember, but I couldn't even think of making any trick to remember it. But I hope you will be remembering by this trick that GD will never be there. So what we studied? DG. Okay, this is how you can remember it. So DC and CG will be easily remembered, but DG gives you Laplacian operator. So divergence of gradient of any field. This I have written scalar field, but Laplacian can be applied on vector field as well. Do remember it. How that is applied, that is of no use. No one is going to ask you Laplacian operator in your examination. It will just be used for solving the problems. Not for the problems actually, for the derivation it will be used. That's why we are studying it here. So what is your Laplacian operator? Divergence of gradient on any scalar field. That is your Laplacian operator. That's it. This is what you need to remember. So first I will calculate the gradient and then I will take the divergence of that. Okay, gradient and then divergence. So this is known by Laplacian operator. So these things you need to remember. That's it. Okay, so these three things you need to remember. This was about Laplacian operator. So when we use in transmission line, I will be using it. So when I say I am calculating the Laplacian of this particular scalar field, then what you will think? At first you will calculate gradient and then you will calculate the divergence. Now this question already solved, right? In last lecture only we solved it. Already solved. So what we are going to do? D by dr r to the power n ar cap. So n r to the power n minus 1 ar cap. So n r to the power n minus 1 r vector divided by r. So n r to the power n minus 2 r vector. That's it. This is the answer. Okay. This we have already solved in detail. A lot of problems we have solved in the last lecture only. So you can refer to that. Null identities. So this is what I was talking about. Two things I asked you to remember. Direct current is 0 and your CG is also very low, that is near to 0 only. Okay. So divergence of curl is 0. Divergence of a curl is 0. But which field? Divergence of curl. So divergence of curl. Which kind of field? If you are calculating the curl, that means certainly it has to be vector field. So divergence of curl is 0. Say yes or no. Now, curl of gradient. What you are calculating? Curl of gradient. If you are calculating the gradient, gradient is always applied on scalar field. So curl of a gradient of a scalar field is 0. So these two are 0, that you need to remember. Okay. Direct current and CGPA. So your CG is 0, direct current is 0. So again I am telling, divergence of curl is 0, curl of gradient is 0. So this you will be able to write down. Now let's solve some questions where this null identities will be used. So see this question and think about it. What they are saying. Which of the following vector can be expressed as the gradient of a scalar? So what did you do? There was a scalar field function you were having. You were having a scalar function. You calculated the gradient and this vector quantity you got. This vector quantity you got. And this vector quantity you got. What you did? You took the gradient of a scalar quantity. If you took the gradient of a scalar quantity, what you are going to get? A vector. So these are the vectors you are getting. So is that possible? From any vector field, is it possible to generate these vector fields? From any scalar fields, by taking the gradient, is it possible to generate these vector fields? This is what they are asking. So if these are valid fields, if these are valid vector fields, then what will happen? What do we know? We know two things. DC is equals to 0 and CG is equals to 0. Divergence of curl is 0, curl of gradient is 0. So this will be applied on gradient. Curl of gradient is equals to 0. This is what we know. So after the gradient, this is the result of gradient. Are you getting this point? All these are del f. This is the result of gradient, result of some gradient function, result of some gradient of a scalar field. If the answer is gradient, then curl of gradient should be 0. And if I call this as a vector A and this as vector B and this as vector C, then curl of vector A should be 0 and curl of vector B should be 0 and curl of vector C should be 0. Say yes or no. If they are coming 0, then certainly vector A is valid. If del cross B is coming 0, then vector B is also valid. If del cross C is 0, then vector C is also valid. If it is coming non-zero, then if it is coming non-zero, then it is not possible for any scalar field function to generate this vector field function. If it is coming non-zero, then it is not possible for any scalar field function to generate this vector field function. Is it clear to you? What they are saying, after taking the gradient of a scalar field, will you be able to get this answer? If I am saying that yes, I am getting this answer, what I am assuming? Assuming that all are valid gradient of a scalar, valid gradient of a scalar, valid gradient of a scalar, then curl of gradient is 0, then curl of gradient, which are this, should be 0. desired. So now what I need to do, I just need to calculate the curl of these values. So just calculate the curl of these values. So ax cap, ay cap, az cap, del by del x, del by del y, del by del z, 2iz, 2xz, 2xy. So this is what I need to write. Now I just need to calculate it. So what I'm gonna get? Ax cap, then del by del y, 2xy, 2x, minus del by del z, 2xz, 2x, plus ay, plus ay, then del by del z, 2iz, 2y, del by del x, 2xy, 2y, plus az cap, plus az cap. So del by del x, 2z, del by del y, 2z. So what you are getting? 0. So yeah, this is valid. Option A is correct. So this vector A, this is a valid gradient of a scalar. What about this? This formula I will write. These are the values I will write. Now I will calculate the final answer. So a rho cap 0, 0 plus a phi cap, a phi cap, oh sorry, rho a phi cap, sorry, and 1 by rho will also come. That I am forgetting. So 1 by rho, then rho a phi, then this, sorry, this into this 0 plus az cap, 1 by rho will also come, 1 by rho az cap, 1 by rho az cap. So what will happen? This rho and rho are getting cancelled. So d rho, d by d rho e to the power minus rho minus d by del phi 0, so minus 0. So what you are getting here? This is 0, but this is non-zero. So what is the final answer you are getting? Minus a rho cap, az cap. Because if you differentiate this, what you are gonna get? If you differentiate this, what you are gonna get? Minus rho a rho cap, minus rho a minus rho, minus rho a minus rho divided by rho. Then rho and rho are getting cancelled. So minus a minus e to the power minus rho, minus e to the power minus e. Yeah, this is very complex to say. Okay, but I hope you must have understood. 0, 0. Here you just need to differentiate it. So rho e to the power minus rho divided by rho. Rho and rho are getting cancelled. So minus e to the power minus rho, az cap. So yeah, that's the answer. Okay. Now so here it is not coming 0. So del cross B is not equals to 0. So this is not a valid vector field, or this is not a valid gradient of a scalar. This is a valid vector field. Vector field could be anything, but this cannot be generated from any gradient of a scalar. From any gradient of a scalar. What about this? Solve it on your own. So a rho cap 0, 0, 0 will come. 0 differentiation 0, and there is no term of z 0 plus rho a phi. Wait a second. Third is also okay. 1 by rho will also come. So here also 1 by rho will come, and rho a phi cap. Then 0, 0 because no term of here if you kill it. So this is 0 and there is no term of z. So again 0. Now az cap. Yeah, now it will give you something. So del by del rho, 1 by rho will also come. Again I am forgetting it. Great. 1 by rho plus. So del by del rho, 2 by rho sin phi. So what will be the differentiation? Minus 2 by rho square sin phi. Then del by del phi, 2 by rho square cos phi. So what is the minus sign will come? 2 by rho square. What is the differentiation of cos theta? Cos phi. What is the differentiation of cos phi? That is minus sin phi, because slope is negative. So minus sin phi. So minus sin phi. So this will become positive here. So this will be cancelled. So what you are getting? 0 only. Again see it, az cap. So d by d rho, 2 by rho sin phi, and d by d phi, 2 by rho square cos phi. So this will be the differentiation of this. This will be the differentiation of this. Answer will be 0. Okay. So this is also valid. So this is also a valid gradient of a scalar. So this is how you solve these kind of problems. Let's see the next one. Which of the following vector can be expressed as the curl of another vector? What do you think about it? DC and CG. This is the curl. This answer is the curl. This answer is the curl. That means certainly its divergence should be 0. I am calling it A vector, B vector and C vector. If A, B and C are curl of some vector, then divergence of curl should be equals to 0. Then divergence of A should be equals to 0, divergence of B should be equals to 0 and divergence of C should be equals to 0. Right? Say yes or no. So I will calculate the divergence of this and divergence of this. Very easily you can calculate it. So do it on your own. Don't see the final solution. See the final answer but not the solution. So this is what I am gonna do. Right? 1 by 2 x square minus y square minus xy plus 2. Okay. So what you are gonna get here? So 1 by 2 will come common. Y square will give you 0. 2x minus. Then x will come common. Plus 0. X minus x, that is equal to 0. So yeah, del dot A is coming 0 only. Del dot A is coming 0. Yeah, now some people will have a doubt. What is the doubt they will have? That sir, in this question, if you had put rho equals to infinity, then it would go to 0 only. You would say that sir, if you put rho equals to infinity, then it would go to 0 only. But these identities are null identities, irrespective of any point. At all the points, they should be 0. Okay. So at all the points, so this point I forgot to tell, all the coordinates I should write. At all the coordinates, this should be 0. Because these are identities. So identities will always work, like cumulative property and associative property. Those properties will always work. It's not that on a specific point it will work. Like, can I say that that 2 cross 2 is equals to 2 plus 2? It is true, right? 2 cross 2 is equals to 2 plus 2. So from here, can I conclude that cross and multiplication both are same? No. So that's why they are not identities, right? But if someone is identity, that means they are always true. We say that A plus B is equals to B plus A. So this is an identity. That's for sure. That A plus B will be equals to B plus A. So at all the coordinates, So here you will not have the doubt that sir, if I put rho equals to infinity, then it goes to 0. No. Okay, del dot A is 0. What about this? This is also 0. What is the term of Z here? Term of Z is not even there. Only phi term is there. So this is also 0. Only phi term is there. Okay. So this will also be 0. This will also be 0. Z term is also not there. So again it is 0. So it is 0 only. So what you are getting? Del dot B is equals to 0. What about this now? Now here 2 cos theta r cube sin theta r cube. R theta phi term is not even there. So that will be 0. What about this? So here r square and this will become r only. So 1 by r square into minus 1 by r square again. Because cos theta, 2 cos theta will come common only, right? 2 cos theta is constant, that will come common. So here you are getting 1 by r, so minus 1 by r square plus 1 by r sin theta. Here what will come common? R cube will come common. So this will become r to the power 4. And this is sin square theta. So what you are going to get? 2 sin theta cos theta, right? So what you are going to get here? 2 cos theta divided by r to the power 4 minus plus 2 cos theta sin theta got cancelled plus 2 cos theta divided by r to the power 4. So what is the answer? 0. So what you are getting? Del dot c is also equals to 0. So yeah, this is also correct, this is also correct. So this is also a curl of another vector. So this is how you solve these kind of problems. High chance that these will be asked in the examination. So this kind of pattern haven't been asked, but it can be introduced in your examination. Well and good. Let's see one more point which I did not write here. We can see one more point. Just now I am remembering it. What is that? What I am gonna write? Some important result. Some important result. What is that? That result is this. Okay. What is there? F is a scalar field function. F is a scalar field. F is a scalar field and P is a vector field. Vector field function also you can say, but a vector field. And you are calculating the divergence of that. So what that would be? It is like differentiation only. First as it is, differentiation of second, plus second as it is, P vector as it is, differentiation of first. First as it is, differentiation of second, plus second as it is, differentiation of first. So what is this? This is a vector quantity, right? Vector, there has to be dot product. There could be cross product as well, but in the whole term there is no cross product. So the cross product will not come, dot product will come. This is a vector, this is also a vector, so there has to be dot product. Are you getting this point? Simply like differentiation. So only this will be used. In some equation, somewhere I will be using it. Well and good. So del dot f p vector. So first as it is, differentiation of second, plus second as it is, differentiation of first. Now you will feel that, sir, why this f cannot come directly outward? So that will come if f is constant. If f is uniform and constant. If f is uniform. Look, it is not necessarily to be constant, because if f is uniform, then it will not be a function of xyz. Look, del is a function of xyz, right? Del by del x, del by del y, del by del z. If f is uniform, that means f is not a function of xyz or rho theta phi, sorry, r theta phi or rho phi z. Z I will write. If f is not a function of these, then f can come directly outward, or you can say del f, gradient of f. What you are going to write? D by dx f ax cap plus d by dy f ay cap plus d by dz f az cap. So this is what you are going to write. Now this is not even a function of xyz. Then what will be the value? 0, 0, 0. So del f will be 0 only. Right? So what you can do? Then your del fp. So this term will be 0. So only f gradient p. So there f you can take outward. So if it is a function of time, then also it is fine. So f is uniform. I said constant, that was wrong. If f is uniform, then f can come out. If f can come out, but otherwise you will have to apply this formula. F, a lot of times I have seen students that, sir, it will come out. No, if f is a function of x, y, z or rho phi z or r comma theta comma phi, then it will not come out. First as it is, differentiation of second, plus second as it is, differentiation of first. So first as it is, divergence of second, plus second as it is, gradient of first. Well and good. Okay. So yeah, these are the results. So I will just highlight what are the final things you need to remember. So this is what you need to remember. F is uniform. If F is uniform, then this will be the answer. So these things. Okay, so it was an easy lecture only. I hope, and might be a bit boring. It might be a bit boring, but even before the starting of the lecture, I told you this might be a bit boring, because here we just understood this was a good question. These two were a good question. So here you might find it interesting. And null identities, this is also good, like the way to remember it. This is also a bit funny. And yeah, this was easy question. This is Laplacian, we just need to remember it. And what else we saw? Then we saw the direction, and we only saw the meaning of direction. We will see the meaning of magnitude in the next lecture. Not useful for you, but yeah, we will see the meaning. And then we just saw these problems which are rote learning, and here also we saw only the meaning of sign, and these were also a rote learning. So yeah, this is what we studied in this particular lecture. Very easy to revise, just very quickly you can revise it. Just revise these formulas, you write down these formulas again and again, and it will be all clear to you. Okay then, so let's meet in the next lecture. We are going to start vector calculus. We are going to study vector calculus from next lecture onwards. Okay, sorry, vector calculus we have already started. We are going to study integral calculus. We are going to study integral calculus from next lecture onwards. Thank you very much.